In this video we're going to look at calculations involving the molar volume of gases. We're going to start by learning about the theory behind the molar volume of gases, and then we're going to look at the formula triangle and go through two example questions. The volume occupied by a gas depends only on the temperature and pressure. It does not depend on its relative formula mass mR. The molar volume of gases is the volume occupied by 1 mole of molecules of any gas. It is 24 decimeter cube or 24,000 centimeter cube at room temperature and pressure. This is the formula triangle for calculations involving the molar volume of gases, and at the bottom we have the amount in mole N times the molar volume Vm in decimeter cube per mole, and at the top we have the volume in decimeter cube. Now let us look at an example question. Calculate the volume occupied by 2 mole of nitrogen at room temperature and pressure. So in this question we have to calculate the volume V, and if we cover up the volume V at the top of the formula triangle, we find that to calculate it we have to take the amount in mole N and times it by the molar volume Vm. The amount in mole is given in the question, it's 2 mole, and the molar volume, remember it's the same for any gas, so we have to remember it, it's 24 decimeter cube per mole. Now we just need to plug in those two numbers into our equation, so we get V equals 2 mole times 24 decimeter cube per mole, and that gives us a volume of nitrogen of 48 decimeter cube. Let us look at another example. Calculate the amount of fluorine molecules in mole in 6 decimeter cube of fluorine gas. Here we have to calculate the amount in mole, which is N, so we have N equals. If we cover up N, we find that to calculate it we have to take the volume V divided by the molar volume Vm, so we get V divided by Vm. The volume is given in the question, it's 6 decimeter cube, and Vm we had to remember because it was the same for every gas, it's 24 decimeter cube per mole. Now we just have to plug those two numbers into our equation, so we get N equals 6 decimeter cube divided by 24 decimeter cube per mole, and this gives us an amount of fluorine molecules of 0.25 mole.